Okay, how you doing? What we're going to do now is that we're going to talk about some exponential laws. We've got something called here the product laws, which I'm going to dedicate this video to. Important thing here is that it's called the product law because this is the operation that has to be occurring with the bases. It has nothing to do with the exponential law, and a lot of people hear the word product and hear it's the product law and think that that's what they should be doing with the exponents. Problem is that that's what you're looking for the base. All of these laws are based off of what the bases are doing. I can't apply any law, okay, for exponents unless the base is doing a very specific thing or it's in a very specific situation. So the product law is based off of, are my bases all being connected through multiplication? And if my bases are being connected through multiplication somehow, some way, then I can apply this thing called the product law. Now, if I have an addition, so if I take some term and I add some other term to it, there's nothing I can do with the exponents. You have to understand that all of this deals with if you have a product of your values. Then you can start to manipulate your exponents in a certain way. And what the product law states here is that if you have some value, so a to the m times a to the n, meaning you just have some value that has some same exact base. And if we use numbers, it would be something like having a base of 4. And I times that by 4. Your intuitive answer would be, well, 4 times 4 is 16. Well, that is absolutely true. But I'm dealing now with exponential rules. And when I'm dealing with exponential rules, they want the answer in exponential notation. Right now, writing 4 times 4 in being equal to 16 is just simplifying the problem. It's not telling me what the exponential rule is with that one. So what I want you to note here is that an exponent, okay, tells you how many times you multiply some value by itself. So in this case, how many 4s do I have multiplied by itself? As it stands, I have 1 4 times 1 4 here, okay, so that is 4 squared, okay? But if I were to continue on with this idea and I go, okay, well, what happens if I have 4 squared times 4? Well, this is the idea of, well, guess what? I already had 4 times 4 occurring right here, and that's why I wrote 4 squared. Well, guess what? I'm now just multiplying it by 4. So what I currently have here is 4 times 4. That's what that exponent means. Well, now I'm just saying, okay, let's times another 4. Well, this 4 here, its exponent, it's just 1 4, okay? So it's 4 squared, which is 4 times 4, times another 4, which means how many 4s do you have being multiplied together? And in this case, it's 4 cubed, okay? So that's the basic idea of what's going on. Now, I can start to interchange and change and mix a lot of things in with this with exponents of variables. And what this basically just means is that my variable has to be the same exact letter, okay? So if it's not the same exact letter, then it's not the same exact base. And all of those letters better be connected by multiplication or I can't apply these rules. So, example of this, okay? So I'm going to get rid of the basic law here. So that's all this law states here, is that if I had something like x squared times x cubed, well, this is where the law becomes very simple, okay? And let me write that a little clearer. So x squared times x cubed. And I want to know what that simplifies to in exponential form. Right now, I can simplify this because what I'm saying here is that I have 2 x's being multiplied together, and here I have 3 x's multiplied together. Well, and in between those 3 being multiplied together and those 2 being multiplied together is a multiplication symbol. I do not want to write this every single time, but I want to point out to you that I have 1, 2, 3, 4, 5 x's in a row being connected by multiplication. And an exponent means how many times are you multiplying some base by itself. And in this case, 5 times. And that's when I would say that the answer is x to the 5th. Well, lo and behold, if you look at the exponents of the original problem here, it was a 2 and it was a 3. All you had to do really was take the 2 and add 3 to it. Remember, this product law does not mean that you get to multiply exponents. The product law is stating that if you have a base being multiplied, And that's the most important thing that you have to memorize. It is not something that anyone can teach you. It is not something that anyone can say to you that, oh, you're doing this wrong every single time. It is something that you have to put to memory, that this is what is occurring of the base. And if you don't commit that to memory, you are going to mix it up with the next law that I'm going to talk about because it changes something, and it's called the power rule. But we're going to stay focused on this product rule. You have to commit to memory that you are multiplying the bases. So you have to have it all connect together in a strand of multiplication and nothing else. There can be no parentheses there can be no parentheses with exponents in between them. Nothing. It all has to be one strand of multiplication. Now, the thing we need to be careful about is how I just said there can be no parentheses with exponents in between them. So what I have here, okay, is that I can express multiplication many different ways. And one of the ways that we express multiplication is by putting the little dot symbol, okay, and call that the product symbol. Well, you can also use a back-to-back parentheses, and this is where a lot of people begin to mix up the power rule and the product rule. So the power rule, okay, the product rule, okay, in this case says that if I had x squared and I multiplied it by x cubed. So in this case, I am not taking my bases. So what I'm saying to you is very clearly, this is a base. Whatever I put inside the parentheses, whatever values are in there, they're saying this group has these bases. So this group has a basis of just an x. This group has just a base of an x. Well, what am I doing with these two groups? I'm multiplying them together. So what I can then do is I can look at this group, what does it share in common with this group? And because it's linked together, my groups are linked together by multiplication, then lo and behold, I can then say to you, I can use the product law. And the product law states that if you have two bases that are alike being connected through multiplication, that I can add their exponents. So again, I used the same example for a purpose just to show that the multiplication could look like this without parentheses, or it could look like this with parentheses. So this answer would become x to the fifth. Now let's expand upon this a little bit more, okay? So this is all just with one variable, and most people don't struggle with one variable. It's when I start putting in coefficients or when you put in multiple variables. So then we come up here and we go, okay, demonstrating the product law. Product law, then we now look at this as a, coming up here and I go, okay, what if I have x squared y, and I have x to the fourth y squared, and I multiply them. I now have this new problem that says x squared y, that group multiplying the group of x to the fourth y squared. X squared y is not one base, and that's what people need to understand. It's one group, okay, but it's not one base. It is two bases making up one term. So, with that being said, I have a base of x squared, I have a base of y. And in this group, I also have a base of x and a base of y squared. Now, these two bases here, it's important that these are connected through multiplication, because if these are connected through multiplication, and this group, inside this group is connected through multiplication, and then I say the two groups are connected through multiplication, then this whole strand of variables is all connected through multiplication. And that's something that you have to understand and know and recognize, because that's just what the law states. And if the law states that if I have terms that are all connected through multiplication, that I can use this thing called the product law, which I've gone over, is the idea that the base has to be multiplied together. So in this case, since my bases are all being multiplied together, it's not like I have to rewrite it. You just have to recognize that you have a base that has an x, and you have a base of a y. So what is the exponent that's going to go on the x? Well, the operation says that I can add them. So what is 2 plus 4? Well, 2 plus 4 is 6. So I get a 6 here. Well, how about the y's? Well, the y here, remember, there's just one y. If I don't put an exponent with it, it's just one y. So I have one y here, and I have two y's here. So how many y's multiplied together do I have? Well, I've got 3. So this exponent is 3. And my final answer for this particular problem is x to the 6th y cubed. Okay, so let's bump it up another notch here. Let's do another problem with 3 variables, and let's throw in now some coefficients, because this is the part where people begin to, I believe, mix up the exponents with an actual number. So here we go. So, like we were doing before, where I was doing something like 4 squared times 4, we got 4 cubed out of that. What we need to realize is that those numbers can be simplified, and normally you don't ever see a number in exponential form. It usually is always in its simplified form. And the reason for that is because if you can do an operation in mathematics, you always just do it. So, now let's take a look at another problem. And I'm going to write it a little bit differently. As opposed to with the parentheses, I'm just going to use the product dot symbol. So I'm going to go 2x cubed z squared times 3x squared y squared z cubed. So now I have this big long problem drawn out. And the number one mistake that I constantly see is people go, oh, this is the product rule, I noticed that. So what they do notice is they notice very nicely that all of this stuff is connected through multiplication. This is still a group. The minute I put a product symbol between things, I'm just saying this group. I'm just not using the parentheses, because all parentheses mean is, hey, look at this group first and make sure it's simplified. I don't need to look at any of these groups because they're already in simplest form. So, the reason I didn't put parentheses around them is because there's not a need to. So now that I have this problem, what I'm going to do is I'm going to look at, okay, this is all connected through multiplication. Now, the law is for your exponents. So, the thing that we need to interpret from this is that the product law states that that's what has to be occurring to the base. So are all of my bases being multiplied? Yes, they are. And the next thing you need to look at is what are the exponents? Is a 2 out in front of the x an exponent? Is the 3 out in front of this x an exponent? And if it's not, then I'm not going to add it. Because all of my bases are connected through multiplication, I'm going to multiply them. And that's very, very important to understand. That this 2 out in front of this x and this 3 out in front of this x here are not exponents. They are actual numbers. And they are connected together through one big long strand of multiplication. And because they're connected through multiplication, I multiply them. The idea of adding is only applied to the exponent. And I can't stress that enough. That the product law stands for the bases are being multiplied, so therefore I can add the exponents. So, I take a look at this and I go, okay, I now have what is 2 times 3? Well, 2 times 3, I hope we know, is 6. Now I'm going to look at, after I get that taken care of, that is the very first thing I always look for to take care of. Now that I've gotten this 6 taken care of, what I'm going to do is I'm going to look at, okay, what are my bases? Well, my bases are x, y, and z. So I have an x, I'm going to have a y, and I'm going to have a z. And this is how I always write out my problems. I don't write the exponent with it yet. I just make sure I get my bases down so that I know that I'm going to have my problem. And then I come up here and I go, okay, this x and this x are the same exact thing. So what can I do with the exponents? I can add them. So this has a 3, this has a 2, 3 plus 2 is 5. So down here I write x to the 5th power. I come up here. I only have one y. Well, that's okay. I have just what it is, and it's a y to the 2nd power. Y to the 2nd power plus no other is just still y squared. Okay? And then I look at my z's. Well, my one z has a 2, and the other z has a 3. Well, since they're connected to multiplication, what I can do is add their exponents. So, I come over here and I go z, so 2 plus 3 is 5. Okay? And some other common mistakes here.